Hello guys, welcome back to your favorite educational channel, Master Your Studies. Today, we are diving into one of the most fascinating topics shaping our world, artificial intelligence or AI. Whether you are a student, a tech enthusiast, or just curious about how we got here, this video will help you to understand the amazing journey that led to modern intelligent machines. So stay tuned till the end. Let's explore how far we have come and where AI might take us next. Computing trend. Computing has evolved significantly over the last century. Over time, computers have progressed through different generations, each defined by major advances in hardware, software, and application. In simple terms, computing trend refers to how computer technology has developed and improved over time. This evolution is usually divided into five main generations: first, second, third, fourth, and fifth generation. And now, we are seeing hints of a possible sixth generation emerging. In this video, we are going to explore the main features that characterize each generation in terms of size, cost, speed, and the technologies that powered them. If we look at this figure, we can observe a decreasing curve showing how the cost and the size of computers has drastically decreased over time, making them more portable and affordable. On the other hand, computer speed and performance has followed an increasing curve, showing continuous improvement through the generations. The first generation was approximately from 1940 to 1956. It used vacuum tube as the basic component for memory and CPU circuitry. Here we can see a vacuum tube which look very similar to an electric bulb. The first generation computers were very large, often taking up entire room. They consumed a lot of electricity and generated much heat. They were very slow and unreliable. They were extremely expensive. Only large organizations or government agencies could afford them. Examples include the ENIAC, Electronic Numerical Integrator and Computer, also have the UNIVAC. This is an example of the first generation computer, the ENIAC, which is actually the first electronic computer. We can see how the computer required an entire room. Second generation was approximately from 1956 to 1963. This generation replaced vacuum tube with transistors, which were much smaller, faster, and more reliable. This was the first major step into semiconductor era. Second generation computers were smaller and faster than first generation. They consumed less electricity and generated less heat compared to first generation. The use of magnetic core for primary memory further improved their speed and reliability compared to first generation. They were still very costly. This is an example of a second generation computer. We can see how it is much smaller than the first generation computer. Third generation was approximately from 1964 to 1971. This generation used integrated circuits or ICs instead of individual transistors. The integrated circuit was independently invented by Jack Kilby and Robert Noyce. An IC is a small electronic circuit printed on a silicon chip that contains many components: transistors, resistors, capacitors, etc., all working together. This single invention of the integrated circuit completely transformed electronics, as engineers learned how to place multiple transistors onto a single piece of silicon chip. Computers suddenly became smaller, faster, and far more efficient and reliable. ICs are produced using photolithography, a process that prints all circuit components onto a silicon wafer. Third generation computers were smaller, cheaper, and more efficient than second generation computers. They consumed less electricity and generated less heat thanks to the integrated circuit. They had an improvement in speed and reliability compared to second generation. They were still costly but more affordable. This is an example of a third generation computer. We can therefore say that the development of ICs transformed machines that once filled entire rooms into devices that could fit on a desk. From the third generation onward, almost every advance in computing came from making ICs to integrate hundreds, thousands, tens of thousands, hundreds of thousands, millions, and even billions of components, making them more powerful and complex. The fourth generation marked the creation of the microprocessor. The microprocessor contains the entire CPU on a single, very large-scale integrated circuit. This innovation gave rise to personal computers, PCs, and revolutionized computing. The PCs also led to the development of the internet. In simple terms, very large-scale integration allowed tens of thousands of components to fit on one tiny chip. That is how we got from room-sized computers to desktop and laptop PCs. The Intel 4004 chip, released in 1971, integrated all the components of the computer from the central processing unit and memory to input-output controls on a single chip. It was the first commercial microprocessor, and it marked the start of the PC revolution. This is an example of a fourth generation computers, also known as PC or personal computer. In the fifth generation, very large scale integration technology became ultra large scale integration technology, resulting in the production of microprocessor chips having 10 million electronic components. This generation is based on parallel processing hardware and also artificial intelligence, such as virtual assistants like Siri and Alexa, large language models like ChatGPT, Gemini, and DeepSeek, self-driving vehicle and AI robots, etc. AI is an emerging branch in computer science which aims to make computers think and learn like humans, capable of understanding language, recognizing images, and solving complex problems. Modern AI system and supercomputer, from cloud data center to mobile phone, are all powered by advanced silicon chips using ultra-large scale integration technology. Examples of fifth generation computers include the desktop, the laptops, the tablets, smartphones. These are examples of fifth generation computers. The sixth generation is still in development. It expects to involve quantum computing, nanotechnology, and bio-inspired processors. Systems that can adapt, learn, and process information millions of times faster than today's machines. These computers will use atomic or subatomic states like qubits to perform massive parallel computation, taking computers beyond the physical limit of silicon. From vacuum tube to quantum chips, every generation of computers represents a huge leap in how we use materials and technology. The journey from transistors to integrated circuits and from very large scale integration to AI driven processor all revolves around silicon, the element that power the information age. And this is this for today's lesson. I hope you have learned something new and useful. If you enjoyed this video, don't forget to like, share, and subscribe to master your studies, and hit the notification bell so you will never miss new uploads. Keep learning, keep growing, and as always, master your studies.